Hello students. So in electromagnetic wave already we learn about GOR. Okay, that is the visible region. Visible region means we can observe in our eye. Okay, and its range 400 to 800 nanometer. But students, electromagnetic ray means from sun lots of ray will come. Okay, we can observe only VGO, only white and that 7 different color. But that all rays together is called electromagnetic wave or electromagnetic wave spectrum. Okay, only VGO, visible range, visible spectrum, you can say that is visible spectrum. VGO means visible spectrum. But when all rays together we will calculate, that is called electromagnetic wave spectrum. So one by one I am writing. That is first gamma rays. Okay, and we will write its wavelength also. Wavelength I will write here. All speed are same. Speed is 3 into 10 to the power 8 meter per second. Okay, speed of light. All electromagnetic wave or electromagnetic ray, all speed are same, just like light ray. Okay, light will travel in 3 into 10 to the power 8 meter per second. So everyone speed is same, 3 into 10 to the power 8. So gamma, first its wavelength less than 0.1 angstrom. In angstrom I am writing the value. Then X-rays. Okay, in increasing order I am writing 0.1 angstrom. You have to remember the value. Okay, 100 angstrom. So students, if 50 angstrom light ray will given, that 50 angstrom light ray fall on which range? That will come in X-ray. Okay, 0.1 to 100 angstrom. Then UV rays. Then UV, after UV, VIGOR, VIGOR, visible range. UV will fall from 100 to 4000 angstrom, and then it will come to 4000 to 8000 angstrom. VIGOR, that is visible range, and after that IR, infrared from 8000 to 10 to the power 7 angstrom, and then microwave, and then radio wave. Radio, for communication purpose, we use the radio wave, and it is very longer wavelength. Okay, below lambda is increasing. Okay, lambda means wavelength is increasing. Microwave is 10 to the power 7 to 10 to the power 11 angstrom, and it is 10 to the power 11 angstrom to increase more. Okay, that is radio wave. So all V is same, V same. So there is a relation, you all know, that velocity is equal to frequency into velocity is equal to frequency into wavelength. So students, so from this, if velocity is constant, you can see wavelength proportional to 1 by frequency. Means if lambda increase, below lambda increase means frequency decrease. Okay, so radio wave is lower frequency. Understand? Lower frequency. Now students, one thing you remember, energy proportional to 1 by lambda. So lambda increase means energy decrease. So frequency decrease, similarly energy also decrease. So students, from here, from this electromagnetic spectrum, you can see that gamma rays are higher energy, very higher energy. Okay, that's why it's very harmful. Gamma radiation is very harmful for the health. It will quickly burn the tissue. It can causes cancer. It can destroy the tissue in fraction of second. Gamma radiation. Okay, so it is, and it's for gamma, you can say frequencies from above wavelength is increasing, below, so it is higher frequency. Okay, you just remember one side, you remember, then other you can easily understand. If we go downward, lambda is increasing, wavelength is increasing. Wavelength increasing means frequency decreasing, because you can see here wavelength and frequency is inversely proportional, or inverse. Okay, so frequency decrease, and energy also energy is indirectly proportional with, inversely you can proportional, okay, say that inversely proportional with lambda means wavelength. So wavelength increase below side means energy also decrease. So above first will be higher frequency, higher energy. Then if you go down below, energy become less and frequency become lower and its lambda will increase. Okay. So now students, in your book also you can see that this relation has given velocity is equal to frequency into wavelength, and the relation and all these thing basic I think I have explained properly. Now you have to learn the property. What is the properties of these rays? Okay, some useful properties I will explain in your book. Lots of properties has given, their range, everything has given. You just remember the basics which is coming in exam mode, that I will explain over here. That is gamma rays will need in nuclear study, because it will arise from nucleus in a atom element, radioactive elements nucleus will produce the gamma rays. So as it is originated from the nucleus, so it can use to study the nucleus and higher energetic. Okay. Then students, X-ray, for X-ray I can say, you can say that X-ray used for detection of fracture. In medical purpose it is using, okay, detection of fracture. For the detection of fracture and study of atomic crystal, okay, study of atomic crystal, that is for that purpose also X-ray used. Then students come to the UV, ultraviolet. Ultraviolet ray students, ultraviolet ray will observe, means one mark question will come, that point I will mention over here, that observe, that spectrum will observe in quartz prism. Normal glass prism used for visible spectrum, similarly we need quartz prism to observe UV spectrum. Okay, quartz prism. And so and use of UV rays, that for the sterilizing purpose. Sterilizing means before the surgery, in medicine, medicinal apparatus should be washed properly. Okay, so water is not used for the washing of the medical surgery instrument, that used by the some these ultraviolet rays and acetone, just like acetone type of substance. Okay, so it is used for sterilizing purpose, sterilizing purpose. And because it is chemically active, and it can kill the germs. Okay. Now students, come to IR radiation means, students, infrared means thermal radiation, or you can say means where the term thermo is there, or thermal heat. Okay, that is related with IR. Okay. And students, IR radiation will don't, it will not scatter, it is don't scatter. It is very important, you need to remember, you just memorize this thing. All light ray, all different rays can scatter, but IR will not scatter. It is simply, you can say, it is heat waves. Okay, heat waves contains the IR. And it will, the spectrum will observe in rock salt prism, rock salt prism. Okay, in rock salt prism you can observe the IR, you can observe the IR spectrum. So as student, it don't scatter, it is used for signaling purpose, signal during war. Otherwise students, in war like situation, the condition, environment is like that, red light can't pass if there is lots of fog. And in photography also, photography at night, during the night, thermal sensor, means IR can sense at night, if the weather condition is not good, also in fog situation. Okay, in that condition, IR can sense, okay, sense the situation, and it will not scatter. It can go, as it is not scattered, so it can go far away. So during the signaling purpose it is used. And in photography during the night, IR sense camera is used. Okay. And remote also, remote in TV, remote. Okay, remote control. Okay, TV remote, you are controlling that radiation which is going from remote to the TV, to changing the channels, that is also IR radiation. Okay. So that is all about electromagnetic. No, another two you must remember: microwave and radio wave. Microwave used for cooking purpose and radio wave for the radar and communication, and all their speed is 3 into 10 to the power 8 meter per second. So if you understand, students, what I explain here, all question will come near about from this. Okay, so next class I will explain about scattering of light.